Hey there, my name is Aaron Gardner. I'm now doing the student video number 2 for calculus. Um, so here this is on question 1. It is a one-sided limit coming from the left at x is equal to 4. So, or not x is equal to 4, but as x is approaching 4. So because of that, we can set up a miniature table. I'm going to start at 3.5. Just because I feel that's sufficient. 3.9, 3.99. Sorry, pardon my allergies. I'm very stuffy in this video. So we're going to want to take this equation right here, x squared plus 3x minus 8 over x minus 4, and we're going to plug in each of these individual values for x. So I already did the calculations for these. So what you're going to get is minus 29.5 minus 181.1 minus 1989.01, and for the last value it is going to be minus 19,989.001. So, as we can see, there's not really one value that this is approaching, which tells us it is going towards an infinite number. Now, because it is going further and further towards the negative end of the spectrum, it is going to be negative infinity as our answer, because as x approaches 4 from the left side, it continues to go down like so, almost as if it has hit an asymptote that is undefined. Okay, next, limit at infinity. So same thing in that we're going to set up a table. We're going to set up a table for all of these just for simplicity's sake. Because it's at infinity, really I'm just going to go by tens on this. So I'm going to put one at minus 10, minus 100, minus 1,000. So if you do the same thing as last time, where you plug each of these values into this equation, you're going to get minus 332.91. You're going to get this next number. It has a few decimals, but they're not really needed. You're going to get minus 333,329. So in that first jump, you can already see it is huge. It is not really, you wouldn't think it's approaching anything, because the jump from here, I'll just go ahead and write down the last one too. 3, 3, 3, 3, 3, 3, 2, 9, 6. So this jump was big. This jump was even bigger, which means that it's not approaching a certain value if it's getting bigger as it goes. So with that, you can once again go ahead and tell that the limit at negative infinity is going to be negative infinity. Alright, general limit as x approaches 5. Obviously, if you plug 5 into here, that'll leave you with 0 in the denominator. So you can't just plug in 5 as easily as that. So instead, what we're going to do is we're going to go another table at 4.5, 4.9, 4.99, and then on the other side of that, we are going to go at 5.01, 5.1, and 5.5. So after you do these values, coincidentally enough, will end up being 9.5, 9.9, 9.99. Oh, sorry, I need to hold the camera better. So those first three, you can go ahead and see that it's approaching 10, but we'll do the backside just to be safe. This one is 10.01, 10.1, 10.5. So coincidentally enough, after you plug everything in, it's almost the equivalent of just adding 5 for all of these values, but you can see this is approaching 10, and if you work backwards from right here, that's also approaching 10. So as x approaches 5, the limit will be approaching the value of 10. Finally, because this one's infinity again, I'm going to do another table where we're working off 10, 100, and 1,000. So as I've explained, you're just going to plug these values into the equation. This will give you 0.63636. At 100, it's going to give you 0.9604. Sorry, pardon the handwriting. And then this last one, at x is equal to 1,000, it will be 0.996. So we can tell immediately that this seems to be approaching the value of 1. But instead of going further and further down the line, in case it is an asymptote, which is what is going on right here, I'm instead going to plug in a value of negative 1,000, and if it truly is an asymptote at y equals 1 and the limit is approaching 1, then in theory it will be 0.004 away from 1. So it'll be 1.004 if I plug in negative 1,000, which is exactly what it is. So because we can tell there's an asymptote going on and that these are the exact number away from this asymptote and from what x is approaching as it moves towards infinity, and then we can also tell that these are approaching 1, I can safely and securely say that x is approaching 1. So so yes, by doing tables all these different ways, you can tell that x is approaching negative infinity, 10, and 1. Thank you.